Let's see what this question. This question I have taken from GATE 2015 set 1. This is also 2 marks question. See, when the question comes from the losses types, this will be definitely 2 marks question, and it is very straightforward only. It will be very straightforward and a formula substitute type of a question. Okay, let's see this question. So this question I have taken from GATE 2015 set 1, question number 53, which and this question is for 2 marks. Okay, the question is as follows. The two reservoirs connected through a 930-meter long and 0.3 meter diameter pipe. Okay, the pipe which is connected between the two reservoirs has a length of 930 meters as well as a diameter of 0.3 meters and is also contained one gate valve. Okay, so now the pipe entrance is sharp. So remember they mentioned that the pipe entrance is sharp and corresponding loss coefficient given as a 0.5. Okay, and the valve is half open. Due to this valve half open, there is a loss encountered by the flow, and thus loss coefficient is given as a 5.5. Okay, the head difference between the two reservoirs is observed to be 20 meters. Assume the friction factor for the pipe is 0.03 and G as 10 meter per second square. Now our interest is to compute the discharge after accounting all the minor and major losses in this particular system. Let's draw this diagram how it looks like. So they mentioned that there is a two reservoirs. She is connected to a pipe. Okay, let's say in this pipe reservoir we have this much water level, and in this reservoir we have water level at this location. If I look at the difference in height of water level at these two locations, it is given as 20 meter. Okay, this, let's see if this is the first reservoir and this is the second reservoir, and this pipe diameter how much they give? 0.3 meters, and the length how much they give? 930 meter length. Okay, and the friction factor how much they give? 0.03, and the G as 10 meter per second square. Okay, 10 meter per second square. Now can you tell me what type of there is a gate valve also here. So can you just briefly mention what type of losses we can observe when the flow is taking place from reservoir 1 to reservoir 2? You can volunteer here.
So entrance loss,
Entry loss, correct, entry loss,
then friction,
then friction loss,
and then the bulb. At the bulb there will be one loss.
right, and at the gate wall we have loss due to
Bulbs.
gate wall
Gate losses
and
and the exit loss.
correct, good, loss due to exit. Suppose let's say the total head difference between these two reservoirs observed to be 20 meters. Okay, now if this is the case, then why this 20 meter difference is observed? Because of these losses. Then if because of this all sum of all these losses, so now what we can do is that if we sum all these losses what the flow is encountered, we will be able to we will be getting this 20 meter loss. So what is that? So is nothing but, and the head difference is head difference between the two reservoirs equal to sum of total losses. If there is no loss, you only tell me if there is no losses, there is no loss, then the total head and the reservoir 1 and reservoir 2 will be the same. Consider they both are located in the same height. Assume they both are located in the same height. Okay, so what will be 20 meter equal to entry loss plus friction loss plus gate valve loss plus exit loss. Okay, these are the total losses. Okay, suppose and do we know formulas for all these losses? Yes, we know. So I have shown you the previous slide. So loss of due to sorry, the loss of due to entrance is we know, loss of due to exit we know, and as various pipe fittings also we know, and pipe fitting gate walls also comes under pipe fitting only. Okay. Now again let's write the formula. Okay. So this is a schematic diagram I have drawn in a more neatly. So this is a reservoir one, this is reservoir 2, and the length of the pipe is 930 meters, and the difference in the reservoir levels is 20 meter, and the fixed F is 0.03, and dia of the pipe is 0.3 meters. So, can you tell me what is the formula for loss due to entrance entry?
0.5 b square by 2g.
V square by 2c. Even we know this zero point 0.5. Additionally, in the question they have given loss coefficient as 0.5 also. Okay, that also you can observe. And loss due to friction.
So FL v square by 2zd.
Correct. Good. FLV square by 2GD. And loss due to gate wall.
5.5 b square by 2g.
Correct. 5.5 V square by 2G. And the loss due to exit.
B square by 2g.
Correct. V square by 2G. Now let's sum all these things, all these losses, and equate to the total head loss. So total head loss is 20 meter, and these are the total head losses we encountered, and the flow is taking place from reservoir 1 to the reservoir 2. So what we can do is that, since in all the terms this 2G is common, so we can take this side. Yeah, one hint like hint or suggestion I want to give is that, remember 2 into G value directly, which is 2 into 9.81, which is how much? 19 point, how much? 62. Okay, this value you always remember, because why I am saying is that, since all of you are using this virtual calculator, not the scientific calculator, so in this case it would be difficult for you to enter all using keyboard to enter all these type of things. So it always remember some things can be remembered. Suppose if it said so, otherwise always consider G as 9.81 only. In some questions they'll say that G is 10, then it is a very simple for you, but in the most of the cases G given as a 9, G will be given as 9.1, and if they won't given also, you can assume 9.81 only. In that case, remember this 19.62 will be a good will be advantage for you. Okay, so now what we do is that, bring this 2G this side, to 20 meter into 2G is equal to K into V square plus FLV square by D, K, KGV square plus V square. So you can able to see how I got this particular equation from this T equation. Now what we do is that, we know Ke is 0.5, friction factor we know, which is given as 0.031, so 0.03, and L is given as 930 meters, and we don't know, and D pipe diameter is given as 0.3 meters, as well as loss coefficient due to the gate wall given as 5.5 V square, 5.5, and V square by 2G we know that 2G we go on the other side, so V square left out plus V square. Now what is the common here? V square is a common, so what we do, we'll bring the v square out and we'll just sum all the remaining numerical value. So after doing that, so we get a value of v square equal to 4. So by doing the square root on both the sides, we can get v as a 2 meter. But that is not our interest. Our interest is to compute the discharge, which is equal to q into av. Okay. So as we know, since it is a circular pipe, so the area of the circular pipe, pi d square by 4, and velocity also we know, which is equal to pi by 4 into 0.3 square into 2. The value is equal to 0.1141 meter cube per second. So the range is given as 0.14 to 0.142. This is a range given in the gate solution. Okay. So is it clear? Is it clear, or did I make you more like did I confused you? Yes, sir, there.